I'm going to take a few minutes to show you how I've learned to tune one of these notch type duplexer filters. It's a notch type. These are not pass cavities, these are notch cavities, and essentially what we do is this is my transmit on this particular unit is going to be the low side, and my receive is going to be the high side, higher in frequency. This transmit cavity I'm going to tune so that the transmitter does not transmit any noise at the receiver frequency, and this receiver side notch I'm going to tune that so none of the transmitter power can pass through this filter into the receiver, and it'll make more sense as we go along. This is a notch type duplexer, usually used on mobile radio repeaters. Just to reiterate, we're going to notch the receive frequency out of the transmit side, and we're going to notch the transmit frequency out of the receive side. I'm going to do that using my Motorola Communication Systems Analyzer that has a built-in tracking generator. There are several ways, of course, to tune one of these duplexers. I'm just going to show you the way that I know how to do it using the test equipment that I have and get maximum performance within this piece of equipment's capabilities. So taking a look at this service monitor, I can go to the special functions screen and look at the options that are installed, and I can see that it has a track generator installed. So over here in the RF section, I'm going to select track generator, and over here in the display section, I'm also going to select track generator. Here at RF control, I'm going to select the range for my track generator, and my track generator output is being detected at this antenna input. And what a track generator is, it's a frequency generator that sweeps across this selected spectrum, and this is a spectrum analyzer, and the spectrum analyzer and the track generator are in sync. So at exactly the moment that the track generator is generating that frequency, that is where the spectrum analyzer is sampling that frequency, and they track each other across the spectrum. Here we can see some anomaly that happens at every division. I'm selected at 25 megahertz plus and minus, so 50 megahertz span, and at every 5 megahertz indication there's some anomaly there, and if we reduce our span, we can zoom in on that. We see every 5 megahertz there's some anomaly. Here we have plus and minus 5 megahertz, we have this anomaly, and it won't impact our measurements any, but we just want to be aware of that anomaly that shows up there. So at this point what I've done is I've connected my source, my RF source, to my transmitter input, and I've connected my antenna port to my antenna port here to detect that power. And I'm going to add this 50 ohm termination over here to the receiver port to give us some impedance matching. So in this process I'll be adjusting this frequency quite often and this output level, as well as the range here, the range that we're looking at. So here we're looking at plus or minus 5 megahertz, centered around our receive frequency, which in this case is higher than our transmit frequency. On our duplexer here, we always want to use the high side and low side as the manufacturer had built it. And we can crank up our output level a little bit. If I go too high, I'll get a warning, increase attenuation. We'll be limited to our dynamic range here, but what I'm going to do now is I'm going to start tuning this notch filter to 466 200, and that is my receive frequency. I'm notching out any transmitter noise that may be emitted at my receiver frequency. And I'm just going to start by moving this screw over here and observe my spectrum, and I can see this particular point moving as I turn this rod in and out. I can see that point seems to be associated with that particular notch part of the filter. I want to get that point over to my center frequency of interest. I'm going to move on to the next one and begin to tune that. And now I'm getting my notch at my desired frequency. Moving on to the next rod. Moving on to the next rod, I'll begin to move this last notch. And now I'm getting my notch at my desired frequency. So I'm outside of the range, my dynamic range of my instrument here. I can increase power output some to try to see the bottom of that notch the best I can. Can't really see it there, and I want more accuracy and frequency. And what I can do is begin to reduce the range, and I can see that the center frequency of my notch looks like it's shifted over, but my frequency accuracy increases as we zoom in the range there. Now I can, I'm already at my maximum output level of 0 dBm, so that's about the best image I'm going to get, but I can still continue to tweak this to get that notch to fall very deeply at my desired frequency. Moving that around. Now I can go up and change my range again. Here I'm plus and minus 1 megahertz. We can see we have this nice deep notch here, plus and minus 2.5, plus and minus 5 megahertz. Remembering that part of this little curve over here was that anomaly we had looked at first. And there's our notch deep into that frequency that we had set it at. And that's transmitting the receive frequency into the transmit side, detecting it at the antenna port, notching out any noise that might come out of that transmitter at the receive frequency. Now we're going to switch our cables over to do the other side. So I've connected this up now with our source going into the antenna, because that's where the receive frequency is going to come into the device, right? And then we're going to have our detector, our antenna input here over at the receive port, and we put our dummy load on here, our 50 ohm impedance matching device there. And now let's take a look at what we have. So our service monitor is saying increase receiver attenuation, or in this case, and we could do that down here, we could add 20 dB of attenuation. But what we're going to do instead is we're going to reduce our power output, because this power is coming from our tracking generator. So let's line up what we have. We're still dialed into that receive frequency, and we can see that we don't have a notch lining up with our receive frequency. Our frequency that we're going to notch out of here is going to be our transmit frequency. We don't want to notch our receive frequency out of our receiver side of the duplexer. We want to notch out our transmit frequency, which in this case is 461.2 megahertz. And we want to tune these cavities now to maximize and tune them all to that same frequency. If I can look here, I could see even at a wider, plus or minus 25 megahertz. Here's our notches that are created by these cavities, and maybe we can see how they move. That lower one there, as I turn it back and forth, seems to be moving. That seems to be the notch associated with this, the resonant frequency associated with this cavity. We'll get that down close to where our frequency is in the center there. This next one, let's see where that one is. I see a notch there. That notch appears to be associated with this cavity. Let's see if that is a notch associated with this last cavity. Indeed. And carefully tune that there. Now we'd like more resolution. We'd like to zoom in on that better. We want to see the bottom of that peak. We want to make sure that we're getting maximum performance. So we're going to narrow our range and increase our power a little bit. And now we can begin to fine-tune that. We see if we move this back and forth. If I move one cavity back and forth, to where I get a deep dip. But the dip has to be right on the very center. Right in this, where our frequency is that we want. And the cavities interact with each other. I'll go back and forth on the screws a little bit at a time. I'm kind of making gross movements now. I'm not too much fine tuning. How can we do more fine tuning? Get that exactly at the right frequency. So if we change our range again to a smaller range, plus or minus 1 megahertz, for example, we can get that. We have better resolution, we have better frequency accuracy of what's being displayed, and we can make smaller and smaller adjustments. Here I'll increase our power out again. See the bottom of that dip? You can make smaller and smaller adjustments. I'm going to move that over to the center right there. Going back and forth on the 3 screws. Now we want even more accuracy. We want that to be tuned as best as we can go. We can reduce our range and we get a finer level of detail of exactly what our frequency is with less error, right to 100 kilohertz. Now we can see it looks like we're shifted off from center. We're off 100 kilohertz there. So we're going to make minute adjustments now. That dip is as low as it can go, right down there. There, that's actually better than I had it the first time. Zoom in on that. Zoom in again. Very fine adjustments. Zoom in again. Zoom in again. I think we've maximized that notch. Okay, so here we've tuned both sides, and now I have it set up to put a transmit frequency into the transmit side. I have a dummy load on the antenna port for some impedance matching, and I have our output from the receive side going into our input on our analyzer. Now we should be able to see both notches, because these are connected together, remember, at the antenna point, and we do see both notches. We can see that we're injecting, I'm injecting a frequency at the center right here, 463.7, but it's sweeping from plus or minus 5 megahertz, so it's a 10 megahertz spread across here. And the first notch that we see is our, in this case, our transmit frequency, how our transmit frequency has a notch, and then we can see our receive frequency, because in this case our receive frequency is higher. Here's our receive frequency notch. So at plus and minus 5 megahertz, about 2.5 divisions up is our notch there, and about 2.5 divisions down is our notch there. We've notched the receive frequency out of the transmit side. We've notched the transmit frequency out of the receive side. Now let's try and get in here and make an insertion loss measurement. So for this measurement, what I've done, I've just connected my cables together using this barrel connector, and I've put in my center frequency of my transmit side. I'm going to measure the insertion loss that the transmitter will see, how much wasted power I'm having from this duplexer here. And I've set my range up to the minimum range here, and I'm going to set a reference level. Now we'll quickly see that this analyzer will tell me that anything over minus 50 dBm on the input is too much. So I'm going to adjust this to, let's see, can I make it 51? I have an input level of 51 dBm. And if we go to our level measurement here again, we can see we went from 51, we have negative 51 dBm to a minus 51.7. We have a 0.7 dB insertion loss on this transmit side of this filter. Let's measure the receive side. To do that, I'm going to put my barrel connector again in there, dial that up to the receive side frequency. So, get my barrel connector back in here again. Dial up my receive side frequency. Set my power level to give me a Give me a 50 dBm, or 51, did we say 51? 51 on my input level. 51, now I'll connect it to the receive side. And so we have a 0.8 dBm, or 0.8 dB loss on the receive side. And so once again, going input into the transmit side, output out of the receive side, here's our pair of notches.